Welcome to this presentation entitled One Size Doesn't Fit All, a look at Oracle ADF architectural fundamentals, basically a look into the different types of patterns that you can use to build ADF applications. My name's Chris Muir, I'm a Senior Principal ADF Product Manager at Oracle Corp, and I work for the Oracle Development Tools part of the organization. This presentation, straight from Oracle Open World 2012, delivered to you, the wider internet community, so you can also receive the benefits of this presentation. Okay, in this presentation today, we're effectively going to be covering 5 topics. The first 2 topics related to each other is what are some of the architectural challenges and decisions that you will make that will fundamentally change the way that you build or construct or put together your ADF applications. So ultimately, what are the effects of the decisions you're going to make that may make you decide to pick a different ADF architecture or a different ADF architecture pattern? Those first 2 points then lead on to the third point of the presentation here, the ADF application architectural patterns. And this is probably the most significantly important part of this presentation, where we will go through approximately 7 different patterns or 7 different guidelines or ways of potentially putting your ADF applications together. Now, it's not the complete set, but it's 7 patterns that we've observed at Oracle Corporation that customers have used in the past. Once we've concluded talking about those architectural patterns, we'll then also consider some anti-patterns. And in computing speak or software engineering, an anti-pattern is something that you don't want to undertake. So from our experience, from talking to customers and seeing some solutions out there, we've identified a couple of approaches that haven't really worked very well. So we'd like to highlight those to you as well. We'd like to finally conclude the presentation with some considerations of best practices in terms of putting your ADF applications together or essentially defining their architecture. Let's start out with considering the architectural challenges for ADF projects and the decisions that will affect your ADF architecture. So one of the main challenges for ADF projects out there is that for a number of teams who are adopting ADF today, that ADF is in a way a very sophisticated framework. It's a very large framework with lots of different features. If you were to compare Oracle's ADF to Oracle Forms, you know that Oracle Forms, well, you can build standard CRUD type applications for data entry. But when you look at ADF, well, it's much more than that. It's not just about building screens for CRUD entry. You've got also DVT controls. You've got the ability to export your data to Excel spreadsheets. You've got a lot more facilities that you necessarily had in good old Oracle Forms. So the problem is for new teams who are learning ADF, there's a lot of learning and there's a bit of a steep learning curve. And meanwhile, while you're trying to learn all about the features and how to implement pop lists and task flows and so on, unfortunately, you're down at a very deep level and you might not be sitting back and thinking about the broader architecture, the broader way that you're going to bring all the moving parts of your ADF application together. And this is a bit of a challenge because that first project, it's probably the time when you're trying to show you adopt ADF for the future, but you're so down in the nitty-gritty details that you're not really thinking about the bigger picture. And it's the bigger picture which is also very critical to developing ADF applications, particularly ADF applications that use all the reusable features that are provided by the framework. So with that challenge in mind, one of the major issues is if you make some architectural choices while building your ADF projects, and maybe they're not deliberate choices, maybe they're accidental choices or choices by you didn't know of a certain feature existed. Unfortunately, the ADF architectural choices you make early on in your application can have large or severe repercussions later on. You may discover that, well, you built your application in one way and effectively it provides you no wiggle room later on to re-architect the application to take on some new requirements or some new reusability features. So this is a bit of a problem, and really this is what this presentation is attempting to address, to break you out of having no consideration of architecture into giving you a whole bunch of decisions about architecture so you're well informed to building a successful ADF project. So in terms of architecture challenges, we want to, when picking an architecture, when defining an architecture for our ADF application, to pick one that's easy to learn, one that will grow, one that provides flexibility and ultimately doesn't railroad us into a certain solution down the line. We really want a ADF architecture that can go with the punches, can be flexible and take on any challenges that we put forward in the near future. So, with those challenges in mind, what are some of the architectural decision points that might actually make you change your architecture? Okay, so what sort of decisions may you make which will actually mean that maybe you'll pick a different architectural pattern that we'll present very soon? Now, one of the very first ones and very important ones is that of in fact, team size, skills, and capabilities. As we present the ADF architectural patterns, you'll discover that the architectural patterns actually build up in sophistication. They build up in requirements of the developer's skills, and as such, they may not be applicable to a brand new team of ADF developers. So you really need to pick an architectural pattern that matches the skills of that team. In turn, some of the more sophisticated architectural patterns that you'll see, well, they would be a lot of work for a team of one developer. So they're more applicable to larger teams with the more having more resources available to them. Another decision point that may change your architectural solution is that based around legacy decisions and architectures. Now, it's pretty rare these days that we have the ability to build bespoke or greenfield applications. Normally, we're building a new application to replace an existing application, either piecemeal or replacing the whole application. But often those old applications have a bunch of decisions that were made 5, 10, 15 years ago that will still drive your architecture today. Now, personally, I've been involved in a number of ADF projects before joining Oracle Corporation, and at one particular client, there was a directive that they couldn't actually have applications served to the general public and their internal staff on the same server. They effectively had to be split across two servers. So you had an application that was customer focused and an application that was internal focused. Now that security requirement, that DMZ type requirement actually drove all the ADF application decisions further there. They actually, beyond the actual the original applications, they actually had to split and build two applications rather than one application that could just deal with two different types of users. So you can see here that a legacy decision still had quite a large impact on their existing ADF application design. In addition, with that one in mind, sometimes you're going to arbitrarily decide to build a single application, and other times you're going to arbitrarily decide to build multiple applications. Maybe you want to create one Uber or one large application that has all your subsystems within it, HR, procurement, financials, or maybe you decide you want to actually split those out into separate applications. And then that's really a design point that or a design decision that you might make yourself. Further to that, getting down to sort of the nitty-gritty of one application, you might decide to have an application that's made up of multiple web pages, like traditional web sites, or taking the rich internet application or the RIA type interface to modern application development on the web. You might decide to have one web page, a one shell, or what at Oracle we call the ADF UI shell, one UI shell wrapped around a number of fragments that you're effectively changing within the one web page. Again, that might be the decision that you decide to make, and it will have an effect on the actual application that you build. In addition, another facility that ADF applications, or I should say web applications, have tended to try and avoid in the past, but now most users know that they can get away with, is the ability to run an application in multiple browser tabs. Okay, so this is like an example of connecting to your bank website, and normally they try and hide the browser Chrome from you so you can't invoke more tabs, but smart customers or smart users will know that you can normally take the URL and just put them in more tabs and open up more tabs all to the same website. Now, the problem is a lot of architectures and a lot of frameworks don't take that into account. So you need to take that into account in how you're going to build your application. The following point there, level of reuse. Well, a core feature of the application, the ADF framework, I should say, how many is it's effectively comprised of all sorts of reusable components, such as declarative components, bounded task flow, page templates, task flow templates. We have a lot of reuse available in our framework. It's really up to you to pick how many of those reusable features you want to use. And obviously, if you go for no reusability, you're going to be building lots and lots of components again and again and again. If you go for high reusability, you're going to be building one component once and then reusing it in all sorts of different locations. Okay, that will really change the size of your application, but also the architecture in terms of the number of moving pieces. A further point, which kind of goes back to the team point at the top of this slide, is that of consecutive or parallel application development. Now, some organizations will have small teams and can only really work on one application at a time or one subsystem in an application at a time. But some other organizations, maybe luckily or maybe regrettably, depending on your point of view, may decide because of project pressures to actually develop multiple applications or subsystems in parallel. Okay, and now these will have potentially, this approach will have an effect on your architecture because when you've got multiple teams working on code at the same time, you've got to be very careful that they're not accidentally working on the same literal source code at every point. Otherwise, you get into issues about merging code and all the discipline that's required around those strict change control procedures. So your architecture may, for parallel application development, might decide to actually split your application out into duplicated application functionality in order to allow the teams to continue to develop in a parallel fashion. Application customization here, and maybe I shouldn't really have MDS in brackets there, just forget about the MDS part for the moment. But application customization is along the idea of maybe you're a ISV, an independent software vendor, and you're selling your software to customers, and each one of those customers wants to customize the application to their own, for their own purposes, change logos and so on. In order to do that, you may need to split your application up into the bits that are customizable and the bits that aren't in order to control what your customers can actually get away with. So application customization may actually force you to change the way that you develop your application and deliver it to your customers. Legacy application modernization is the concept of, say, you've got a pre-existing Oracle form system and you're migrating it to ADF. Now, with very large form systems, that might be thousands of forms. So taking a big bang approach to developing and migrating the the Oracle Forms applications to ADF could be a large challenge. So instead, you might decide to do it piecemeal. So you might take a subsystem out of the Oracle Form system and redevelop it. Now, if you do that, well, obviously your architecture is defined by what subsystem that you're building and what next subsystem you're going to take from forms and convert to ADF and so on. So this modernization effort might actually have an effect on the way that you put your application together. Finally, okay, we've been talking about, I guess here, vanilla or traditional type ADF applications, but with the advent of Oracle ADF Mobile and other mobile solutions coming on board, you may now need to think about how you're going to not just provision your traditional ADF desktop applications, but also how you're going to integrate a mobile solution into that space. All of these points, and it's not the superset of all the points, there may be other points that you need to consider, but all of these points will have an effect, if you need to consider them, on the actual application architecture that you build. Okay, so now let's consider the application architectural patterns. These are going to be 7 or so patterns that I'm going to present to you in terms of how to put your ADF applications together. Before we actually drill into those application architectural patterns, let's just consider this quote here that I happened to capture a couple of years ago. And I think it's a beautiful quote because it gives you some idea of what we're attempting to do in picking a relevant architectural pattern for you. This quote comes from the Defense Electronics magazine. It comes from a gentleman called Mark Valentine. And obviously it's got nothing to do with software development. It's got more to do with construction architecture, but I think it's quite relevant to what we're attempting to achieve here in our ADF application architecture. I'll just read the quote out to you. Obviously, it's a really bad thing in a presentation to have lots of text in front of you, but this quote is pretty inspiring, so I think it's a really good quote to actually tell you about. Design engineering is more than a mere balancing act between finding the best options among a sea of possibilities, and then implementing those options through the careful orchestration of available resources. To fully manage the challenges of the software design process, it is also necessary to develop an instinct for choosing design paths and system configurations that provide some measure of flexibility. It's a pretty powerful point there. We want an architecture that will provide flexibility. This flexibility maintains the wiggle room as projects advance towards completion, often creating an angel in the architecture to serve as a countermeasure for the situations in which the devil is in the details. Okay, so we really want to pick a pattern that allows us to change and rebuild our application in terms of an architecture, gives us that wiggle room as our requirements and our learning and our project evolves. So quite a nice quote there to take forward into the architectural patterns that we're just about to talk about. So what we're going to present here is a number of separate architectural patterns. And these architectural patterns ultimately discuss the moving parts within an ADF application and how they come together, or they're composed or separated to make an ultimately the ADF applications that we're interested in. In presenting these architectural patterns to you, we're going to consider the pros and cons of each application architectural pattern. And ultimately, to do this, or why we're doing this, is so you can match the patterns to your requirements and capabilities. So what's in scope here is we're talking about the application architectural patterns within an ADF application. Broadly speaking, when we talk about enterprise architecture and system architecture in computing and IT, we're talking about the architecture across systems and the integration of those systems, and including things like server, hardware, and network topologies. For this presentation, that is not our focus. We're focusing purely on ADF application architecture patterns, or all the moving parts within an ADF application. In addition, with these patterns, I'd like to throw some quotes up in front of you. The best laid schemes are mice and men. No plan survives first contact with the enemy, or one size doesn't fit all. The point of highlighting these quotes to you is that there isn't one pattern that fits all situations. Oracle is not proposing a pattern that will be the ultimate pattern that all customers should use. There is no one best practice pattern that we are going to advise you on. In the end, we are just dictating a number of different patterns, and there are patterns beyond this presentation, but a number of different patterns that we want you to consider, to look at the merits of each, to understand, maybe one of these patterns would be good for us and against our particular requirements, and maybe some of the other patterns won't work for us. Ultimately, we're giving you a number of different guidelines, and it's up to you to pick the pattern that matches your requirements going forward. You may decide, after looking at some of the patterns that we're going to present here, to actually go with a hybrid pattern, to pick a combination of patterns, or you may have a different idea. But ultimately, this presentation and outlining a number of different patterns will hopefully give you an idea on what you should be considering about in picking these architectural patterns, what you should be documenting, and what you should be essentially looking against your particular requirements. So in this presentation, we're going to look at approximately 7 patterns, and what we've got here is effectively a genealogy of the patterns that we're going to present. You'll notice we've got different colors here. On the left-hand side, we've got green. On the right-hand side, we've got red, and then a gray pattern. What the different colors here are used to indicate is the left-hand side patterns, that is the small and simple application architectural pattern, the monster pattern, and the sum of the parts pattern. These are really an evolutionary approach. What we'll find is they're actually building in more and more sophistication and changing quite radically. But when we get to the sum of the parts pattern, really all the patterns thereafter are really just a derivative of the sum of the parts pattern, in the sense that, well, it's going to, once you see it and understand it, it's going to open up a whole range or sea of possibilities for you building ADF applications. And really the patterns in red on the right-hand side are just permutations of that, which just take different, just implement different, slightly different options to get different results. The gray box, the fine grain pattern, is in fact an anti-pattern that we'll present to you so you can kind of learn from a mistake that it is potentially a pattern that you don't want to pursue. And it's often good in presentations and in technical presentations to talk about the wrong way, or things that were built from experience and we decided with the wrong way to do things, because then we can all sort of share that experience and sort of know the limits of taking, ideas far too far. So let's start out though with the small and simple application architectural pattern. Okay, the characteristics of this small and simple application architectural pattern is, from a JDeveloper or ADF perspective, is we're going to have one JDeveloper application workspace, and as a result, one deployment here at the end of this particular pattern. Now, just like a standard Fusion Fusion templated application. This application workspace will have a model project and a view controller project. And for the purposes of this presentation, we're really just talking about ADF business components and Java server faces and ADF faces with the task flow facilities. Now, within the model part of the application, the ADF business components, there will typically be one application module, remembering this is the simple or small pattern. And as a characteristic, all that transactional support will come through through our root application modules. Now, this point is a little bit out of the blue here, but we will talk more about transaction support as we get into the more sophisticated patterns. In context of this pattern and the view controller project, we have one unbounded task flow and no bounded task flows. Okay, so for the purposes of this pattern, it's very simple. It just includes a UTF or an unbounded task flow. Now, those are obviously bullet points there, a little bit hard to digest. Let's show this in a diagrammatic format so it'll be easier to understand. Right, what we're going to start out with is one application workspace. And in that application workspace, we're going to have a model project, which is made up of a number of business components, such as entity objects, view objects, application modules, and potentially framework extensions. In the view controller project, we're going to have an unbounded task flow made up of one-to-many pages. In addition, that view controller project may be comprised of other reusable constructs in ADF, such as page templates, declarative components, skins, and view controller extensions. In context of that workspace, there is only one deployment artifact generated from it, an ear. And that ear obviously goes onto our WebLogic server or Glassfish or whatever, but we only have one deployment artifact, and that's the point of that annotation there. When designing with this particular application architectural pattern, okay, some of the design considerations are, from the model perspective, is potentially how many root application modules we're going to have, just one or multiple. And that really defines the number of transactions each user session can take out. From the view controller perspective, this particular architectural pattern, okay, is really based around how standard web pages are designed. It's going to be a page-by-page design, okay? And overall, there's very little consideration of reuse in terms of the pages. Now again, this might all seem a little bit basic at this stage, but we're building up to some more of these sophisticated patterns, so just bear with us at this stage. In context of this application architectural pattern, the advantages of it is it's very simple, right? It's all self-contained within one workspace, and deployment and building and deploying really is just a one-click affair. We just go to the view, the application menu, I should say, the deployment options, and off we go. Because this application architectural pattern is so simple, it particularly suits small teams or beginning teams or small applications. And you notice I keep on saying and or in that slide there. The point being is this architectural pattern, while it's quite simple, it doesn't mean we shouldn't not use it for all types of applications. In fact, some types of applications later on, even though you'll be a sophisticated ADF programmer with lots of experience, some of the applications you're right will still be happily could fit into this particular pattern. You shouldn't discount it just because I said it's small and simple. However, because it is small and simple, it does suit teams who are just starting out with ADF and dealing with learning the platform and the learning curve, who have a few challenges in front of them. This architectural pattern, because it doesn't have a lot of architectural moving pieces, is particularly easy to pick up and use. In addition, because this is a one-click build and deployment affair, we don't need many other tools to support us, such as continuous integration servers or application lifecycle management tools. We don't need Hudson servers and Jenkins servers to build these applications, though we can certainly use them if we want to, but we don't need a lot of infrastructure. Again, from the perspective of a new team starting out, therefore this is particularly good, right? We don't have to get all this infrastructure into place if we don't already have it. We can focus on learning ADF at this stage, and then later on bring these tools in when we get into more sophisticated architectural patterns. From the disadvantage point of view for this particular pattern, well, one main point is that it is poor mapping of business processes to technical solutions. What does that mean? Well, a key reusable facility within ADF is bounded task flows. And bounded task flows are one of the truly powerful parts of the ADF framework. They really allow you to create nearly business processes or a bunch of web pages that map to business processes, if that makes sense. Because about enterprise applications, particularly web applications, they're not really just a bunch of web pages with some information on them. They're more about business processes, right? So imagine you're building a student-based system for university enrollments. There's all sorts of processes within that sort of application, such as enrolling students or changing library cards or finding students for overdue books. They are all business processes and all have a number of web pages that are a business process, and these map to bounded task flows. But we're not using bounded task flows in this architectural pattern at this stage. So, we're sort of losing an opportunity to talk to our business analysts and our users in the same language that they talk in. From a very technical point of view, from a software engineering point of view, because we're using this architectural pattern and we're not using bounded task flows, it's very easy for our programmers to tightly couple code to accidentally create poor modularization and ultimately have poor separation of concerns. Because the developers are all working on the same workspace and the same projects, it's very easy for programmers to accidentally break each other's work because they're actually working with the same code. It would be nice if we could get them onto separate code, but no, we're all embedded in this one workspace here, so we can effectively trip each other up. In addition, because programmers are essentially working on the same code, it's quite easy for them to accidentally reuse or tightly couple code, sort of create a bit of a spaghetti mess. And because of that, when you step back and try to unit test this thing, geez, unless our programmers have been very careful, we may not be able to unit test things because we have tightly coupled code or poor modularization. Because of that tightly coupled code, later on, the wiggle room that we're looking for, the ability to re-architect our application to move bits around, may also be quite difficult. So this architectural pattern doesn't lend itself towards good coupling, I should say loose coupling, good modularization and separation concerns. Disciplined project teams might be able to achieve it, but the architectural pattern naturally doesn't support it. In addition, we talked about building and deploying. Well, as our solution here grows and grows and grows, our build is still an all or nothing affair. Okay, because of that one-click model, there's no ability to say, well, I only changed a little part of the application here. Can't we just compile that and redeploy that? No, you've got to do the whole thing. With that in mind, that really moves on to the next architectural pattern referred to as the monster architectural pattern. And really this is an extension of the previous architectural pattern, the small and simple application architectural pattern. Geez, it's a bit of a tongue twister after a while. The monster architectural application pattern, the characteristics of it are, well, one of the things is it's synonymous with the German term Über or the concept of monolithic. Now, just to be careful here in defining this architectural pattern, we're not trying to say it's a monster as in something that scares your kids, but what we're trying to say is it's a monster in terms of the size. Okay, and the size, why it is the size of this application architectural pattern will become relevant in just a moment. Ultimately, this architectural pattern still has one workspace and one deployment ear, but of significance, unlike the previous pattern, is while we still have an unbounded task flow, we now introduce bounded task flows, and we might have one too many of those. The sky's the limit in terms of the amount that you have. And because we introduce these bounded task flows, it is now really an extreme contrast to the simple application architectural pattern. We'll see that the application can actually get significantly large, i.e. monolithic or Uber. Let's again describe that diagrammatically. So we have one workspace, and like the previous architectural pattern, we have a model project with ADF business components in it. And there's not really much of a change in context of this application pattern. But where it does change is when we get to the view controller layer. We have, yes, our unbounded task flow, but now not only our reusable components, but many bounded task flows. And in this diagram, I happen to have 3, but there can be as many as you want, okay? Now, this is what makes this monster application architectural pattern get its name, because there could be thousands of those. In terms of the actual application architectural pattern, well, there's still one e-deployment that's actually deployed, and he's going to get very large based on the number of BTFs or bounded task flows that you actually have. Just before we skip off this slide, I just want to highlight a little point in this slide, as you might notice that the bounded task flows are not based on pages, but based on fragments. And that's a general recommendation for building reusable bounded task flows, because if you base bounded task flows on pages, if you ever want to place one of those bounded task flows in another page, you can't put a page in a page. But later on, if you have created your bounded task flows out of fragments, okay, to embed that fragment in a page, well, it just becomes a region. But if you ever wanted that bounded task flow fragment to be page-based, then all you need to do is wrap a page around it, okay, and then you put the bounded task flow fragment as a region in that page. So generally, we use fragments for bounded task flows because it gives us flexibility down the line to either embed them as regions or embed them in regions in a page that we've just created for that purpose. Okay, so a general recommendation there. Let's go back to the monster architectural pattern and consider that. So the design considerations of the monster architectural pattern are interesting because once we introduce bounded task flows into the mix of our design, we instantly hit the question of the granularity, sorry, I nearly said that like an Australian, the granularity of bounded task flows. I'll get it out. So if you have a background in service-oriented architecture or SOA, and you know within the SOA space they have web services, one of the continuous problems for the SOA world is the granularity of web services. When you have to define a process or a web service, do you create one large one made up of a number of little operations that it does behind the scenes? Or do you create lots of little web services that have a one-to-one mapping with each one of those operations? And the caller, rather than calling one large web service, has to call them all separately, all these little web services. Now, both approaches have advantages and disadvantages. From the developer's point of view, the one large web service is much easier to design, but from the consumer's perspective, well, they can't call the individual operations within that large web service, so there's not a lot of flexibility there. From the flip side, having many web services and sort of a mapping to one for operations, well, the problem with that is, well, great for the consumer, but bad for the publisher of the web services because now they've got to actually define lots of them, okay, and maintain them. So there's no real winner in either choice. You can't have a win-win solution. And if you can take that idea of this granularity of web services, and then you think about bounded task flows, the same issue applies. How fat or thin do you make your bounded task flows? And is there a one size that fits all for your application? Now, there is no recommendation we can make to you. You just need to be aware that it is something that you need to consider. And I think if we were to make a recommendation to you, it's not to tell you use fat bounded task flows or thin bounded task flows, but try to be consistent. Try to think about the architecture of your application such that the development teams always know how fat they should be making their bounded task flows in terms of services. And in addition, that the maintainers down the line who get the application that you've built also have a general understanding. The advantages of this particular architectural pattern is, well, in a way, it's still a fairly simple architectural pattern. I mean, we've got one workspace, we've got a couple of projects. It's really the bounded task flows that introduce a little bit of sophistication and complexity. The bounded task flows, even though they do introduce some design complexity, they do have a lot of advantages. One of the primary advantages is that ability now to talk about, well, business processes in your web application. They have this nice mapping and such that you can really be talking about processes with your business analysts and users. In addition, bounded task flows create a modularization in your overall architecture because you now have, rather than a whole bunch of code that potentially is molded together, you can now say, well, this bounded task flow takes care of those operations and this bounded task flow takes care of those operations. And hopefully you can have a separation of concerns there. It's not perfect though, because you're still coding within the one workspace, but we're on the way to creating a more modularized application architecture. The bounded task flows also introduce the ability to support transactions at the task flow level. So where traditionally in JDeveloper or ADF, we might have used multiple root ADF business component application modules to do that. The bounded task flow transaction options now introduce that facility. So basically we're kind of moving our design or where we can make those choices, which is kind of a good thing. Another interesting aspect of introducing bounded task flows, and this is one that comes from all sorts of programming paradigms, is the concept of programming by contract. Bounded task loads have a very strict API, just like a 3GL function or procedure, that they have a number of parameters, inputs and outputs. And you can pretty much define the same thing on your bounded task loads. And you can do that at design time. Literally, you can give out design documents to your teams and say, well, here's the bounded task load, here's the inputs, that's the expected outputs. This is what I want you to do within the bounded task load. You go and build that. That's a good thing. In addition, because we have this modularization now occurring in our bounded task flows, we also start to get an improved ability to test our modules because we've got more standalone pieces within our application. Surely, we still want to do a complete integration testing of our whole solution, but we've also got the ability now to do unit testing at parts of our modularized solution. Because there's a greater separation occurring, we can now do that. That's a good thing too. Disadvantages of this particular architectural pattern, because we're still working in the one workspace, well, developers can still accidentally tightly couple code because the architecture doesn't separate them. This is still an accidental thing that can occur, and it's something that beginner teams may quite easily do. Build is still an all or nothing affair. One little change requires the whole application to be rebuilt and redeployed. Unit testing is still kind of complex because we haven't solved the 100% modularization issue. We still have potential for tight coupling. Therefore, regression testing. Now, regression testing is something that you need to be aware of when you're building applications. You really want to minimize the number of regression tests of the complete application that you need to do. And because we can't guarantee here that effectively we've separated our solution out and a change only affects a small part of the application, we probably still need to regression test the whole application when we roll out changes. Another interesting thing about bounded task flows here is, well, at this stage, well, bounded task flows are meant to be very reusable, but they're only reusable in context of this application architectural pattern at the moment, or this particular application. It would be kind of nice if once we start building these bounded task flows, just like other code constructs, like our Java classes, the functions, our declarative components, it would be really nice if we could actually make our bounded task flows reusable and externally reusable to other applications too. And you can sort of guess where this presentation is going to go. The bounded task load transaction options that we also talked about on the previous slide are not for the light-hearted. They do introduce some design complexities into our system. Now, there is a white paper available from Oracle on that called the Task Load Transaction Fundamentals paper. Go and search for that particular paper. It will give you an idea of what you can consider. We won't go into that any further in this particular presentation. Okay, let's now consider the sum of the parts architectural pattern. And this is really, as we said, we're building up into a more sophisticated patterns here. And this particular pattern, once you understand it, it will really open your eyes to the power of ADF applications and the ability to reuse. Okay, the characteristics of this particular pattern is that there will be a single master, now listen to the terminology, master, or I might use the word composite, a master application workspace with the unbounded task flow. And there may be a separate application workspace with the model. Okay, so remember the ADF business components. There may be a separate application workspace containing the model, which will be published and consumed as an ADF library by the master and the additional bounded task flow workspaces we're just about to talk about. In addition, this application architectural pattern will have one-to-many separate bounded task flow application workspaces, which obviously contain bounded task flows, and in addition, they will be published and consumed as ADF libraries. Okay, again, text, a little bit hard to understand. Let's break that up diagrammatically. Should make it a little bit clearer. So what the sum of the parts architecture does is it says, okay, we're going to have a common workspace, and the common workspace is going to contain our model project, and our other projects include, our reusable components such as declarative components, skins, and whatever else. Now, each one of those is going to be deployed as an ADF library and potentially consumed by, in addition, our bounded task flow workspaces. And our bounded task flow workspaces will include a view controller project with one-to-many bounded task flows within them. Now, how many bounded task flows you have is up to you, but let's say minimum one, maximum infinity. Now,
You may also have, additionally, other bounded task flow workspaces. And how many bounded task flow workspaces you're going to have, again, up to you. But the point here is we've broken our bounded task flow workspaces away from the main application. Now that main application, called the master application or the composite application, it's going to reconsume the ADF libraries of the workspaces and also the common workspace, and ultimately consume all those and present its own view controller project with the unbounded task flow with the pages that consume the bounded task flow workspaces and the bounded task flows that we just talked about. The end result here, though, is still one EAR or application deployment artifact. And that really, just seeing that picture should really start to highlight the ability to break your application into multiple moving workspaces and reusable components. Okay, this guy really opens up your world into as we say, a sea of opportunities. So what are some of the design considerations of this particular architectural pattern? Well, questionably, what logical functionality goes into each bounded task flow application workspace? I mean, you can have one to many of those. So in one bounded task flow workspace, do you put all the bounded task flows for HR and another one all the bounded task flows procurement and another one for financials? Or do you have some sort of other logical divide about what bounded task flows go into each bounded task flow application workspace? It's up to you. You've got to decide. The question of the granularity of each BTF is still there. We haven't left that question. We haven't solved that issue. That's, again, up to you. Task flow transaction options are very important. And is reuse a consideration? We'll come back to that in the next architectural pattern. You do get some deployment considerations here. Because WebLogic Server allows you to create what's called shared libraries, you can actually deploy your ADF libraries separately to the WebLogic Server. Okay, so if you've got 20 ADF libraries, you can deploy those as separate deployment artifacts to the WebLogic Server as shared libraries, and then deploy an EAR that references those, or you can deploy an EAR that has all the ADF libraries embedded inside it, so it's still just one deployment artifact. Okay, and that's a choice you can make. Now the advantages here is, well, if only one of the bounded task flow workspaces change and you are using WebLogic shared libraries, you can actually just redeploy that part rather than the whole application. However, a little caveat, be careful, because when you use WebLogic shared libraries, you actually discount a feature of WebLogic Server called, and it's a high availability feature of WebLogic Server called production redeployment. Production redeployment is a feature that allows you to, and it's a very, let's call it a high availability feature. It's a feature that allows you to actually have a version of your application running on the server with connected users, and you wanted to redeploy a new version of that application. What it allows you to do is, rather than just disconnecting that application and all the users, undeploying it, and hey, some users are going, hey, where's the application gone? And then redeploying the new version, what it actually allows you to do is gracefully switch between versions such that the existing application or the previous version is still there with the connected users, and once they finish, well, they basically disappear, the old application is undeployed, and meanwhile, any other new users that come on, rather than accessing the original version of the application, they will have already been moved over to the new application version that's been deployed. Well, that feature, production redeployment on WebLogic Server, requires that you don't use shared libraries. So just be a little careful there. Now, we're not saying you can't get a highly available solution. And what we're really saying is, well, there's different definitions of highly available. And in this case, this particular feature of gracefully switching user sessions over from one version to the next, this reproduction deployment feature, well, if you use shared libraries, it won't be available to you. So you just got to consider it. In terms of the sums of the parts architecture and the advantages that it gives to you is you now have the full power of bounded task flows to you. And this opens up concepts of total reuse or extreme reuse. In addition, you have excellent separation of concerns, because what you can do now is literally put bounded task flows off into your own workspace, and you've totally broken them. They're physically broken in terms of the application architecture. And so they really do have a separation of concern, which is really a loose, I should say, a good modularization. In addition, loose coupling, because the BTFs are now self-contained, and you can actually test those BTFs because they're standalone, and test them and do unit testing on them without being worried about that there's some other code that's been accidentally tightly coupled in. The architectural pattern here too, once you're realizing that you're breaking your solution up into multiple parts, is very much suitable for large projects and teams. You know you've got architectural pieces that you can give separate teams during the development of your application. And this kind of goes under the last bullet point here, and having been a team leader in the past, I think this is a very important point. You can now give different team members or different teams of your organization responsibility for parts of your application. The problem with the previous architectural patterns, because you could never 100% guarantee one programmer hadn't affected the work of another programmer. Now, when you give out the different bounded task flow workspaces to be worked on, so you could say to team A, you've got to work on these bounded task flows, and team B, you've got to work on these bounded task flows in these separate workspaces. When those bounded task flow workspaces break or don't do their job, you know clearly who's responsible for them, and so do the developers. So there's much better ownership, okay, in the overall development environment. And it's interesting here, while ADF is a technical solution, we need to also consider, software engineering concepts and also human concepts in delivering applications and constructing applications. So I think this is a very important point to highlight in the overall architectural patterns here. The disadvantages of this architectural pattern is it's definitely more complex, okay? It's more complex, more sophisticated, and when you've got beginners who are starting out with ADF, they're trying to learn about how to build screens and pop lists and partial triggers. If you start throwing in all these issues of breaking your application into multiple workspaces, creating ADF libraries and reconsuming them, that is going to add a greater learning curve. So not the first thing that you want beginner teams to approach. If you're going to force beginner teams to approach this, get an expert on board who can help take the pain away and the learning curve away here, and get you over this. Don't let purely beginner teams approach this architectural pattern. In addition, because of this architectural pattern, you start to get some dependency management issues. Think about it. You've got a master workspace that consumes other bounded task flow workspaces. And maybe one of your teams has given you bounded task flow workspace version 1. Great, so the master workspace is dependent on that. But hey, you find a bug in that bounded task flow workspace, so now you need them to go and fix it. And they go away and build you version 2. Right, so is the master workspace dependent on version 1 or version 2? Ooh, we need to start tracking this stuff. So build management now becomes an issue as well, because you've got to keep a track of what versions and how to build these applications, and who's going to build the application? Isn't it going to be manually built? Maybe we need some tools to assist us here. That's where tools like Hudson's and Jenkins and continuous integration servers come in. In addition, because our bounded task flows are really becoming reusable artifacts now, it's not only just about building your bounded task flows for the current consumer, but maybe you've got to think about building your bounded task flows for flexibility of future consumers out there. What are all the different ways that this particular bounded task flow workspace and its bounded task flows will be reused? You need a bit of a crystal ball. In addition, this architectural pattern has some interesting side effects. The fact that you start to lose some ADF features. And the last bullet point here alludes to the fact that if you have ADF BC security, okay, so this is security at the ADF BC level, at the moment in JDeveloper 11G, well, effectively, once you put the model project into a separate workspace, effectively that feature can't be used anymore. The ADF BC security feature only works if the model project, the ADF business components, actually reside in the composite or master application. Okay, so sometimes we lose some features. Now let's talk about an extension of the sum of the parts pattern. So the sum of the parts pattern really allows us to start to realize, oh, we've got a whole bunch of different things we can achieve. And we're going to look at the 2-for-1 deal architecture, which is a derivative of the sum of the parts. Okay, the 2-for-1 deal architectural pattern basically realizes that once you start putting bounded task flows out into their separate workspaces, that you can start to reuse those bounded task flows across applications. Let's diagrammatically look at that again. So in this diagram, we've got a number of bounded task flow workspaces, and more than one master application. And some sites you may only ever have one application that you're building, but it's not uncommon at customer sites, or I should say on software projects, to actually build separate applications. Now, those separate applications, though, may have the need for common functionality between them. So in this diagram, that common functionality is the bounded task flow workspaces. So some of our bounded task flow workspaces might be consumed by one master application, others by the other, but you may potentially have bounded task flow workspaces that may be used by both master applications or one or more master applications. And this is where we've got real reuse coming in. Not with use just within one application, but reuse across multiple applications. The design considerations of this architectural pattern is, well, if you know you want to go for this total reuse model across applications, and potentially you've got not only the application you're building now, but applications that you're building in the future, you need to, as I said before, you need to have a bit of a crystal ball. You need to think about, well, my current requirements say the bounded task flow should do this, but I could also see that in the future it would be really useful to add an option that it did this. Should I include that now or not? Challenging decision. You could do it now, but what happens if it's never used? Okay, you could be building things that will never use and you'll have to maintain that code regardless. But the flip side is well, if we don't build that option in now, well, the problem is later on we might have to come back and extend this bounded task flow. And when you come back and extend it, you've totally forgotten what the original bounded task flow does. It takes you a while to context switch, relearn, see what the bounded task flow does, and it's not really good to do that sort of stuff down the line. It'd be better if you did it when you first built it. Which choice do you make? Difficult, isn't it? And there's no solution here, but this is the area that you're getting into, extreme reuse. Another challenge is, as well, as you build more and more applications and more bounded task flow workspaces, is, have we already built that bounded task flow previously? This reminds me in the SOA world or the web service world where they have the concept of UDDI registries. And the purpose of a UDDI registry is to give you a list or effectively a directory or a phone directory, to coin a phrase, of all the web services that are available. Now, eventually in your ADF development with bounded task flows, you're going to have exactly the same problem. You could have 10, 50, 100, 500 bounded task flow workspaces. And currently in JDeveloper, there is no tooling to help you realize all the different bounded task flows that are available and in particular what they do. Maybe their name might help you, but even so, how do you make sure that you don't miss one of the names, or the names is slightly complex and you misunderstand it, and you start building the same bounded task flow workspace again? That can happen, okay? So this could be an issue. So the concepts of reuse here are very, very important, and it goes to the level of reuse that you want to achieve. Very flippantly, we may say we want total reuse, extreme reuse, but reuses at the extreme level can also be a hindrance to our application development. Will consume more development time, and you may develop things that may never want to be reused. The flip side is maybe they are going to be reused, and you need to make the things that you're building extremely flexible. The advantages of this architectural pattern is obviously the benefits of the sum of the parts pattern that we talked about previously, and this concept here that when you get to this level of reuse, it really does feel cool. You kind of feel like that you've reached the nirvana of software development because, even when you go back to university or any formal training, you've had it battered into you that reuse is very important. Only code stuff once and reuse it all over, okay? But disadvantages, okay, there are some disadvantages that really come into play here. Certainly the disadvantages that we talked about in the previous pattern, but we also get a number of disadvantages in terms of the build. With this particular architectural pattern, dependency management can become a nightmare unless you're very, very disciplined and you use tools to support you. Why? Well, think about that diagram that we just saw previously, where we had two applications dependent on the same bounded task flow workspace. And say that bounded task flow workspace is version 1. Now, application A says, great, we've been using your bounded task flow workspace for quite a while, but we would like a change. Oh, okay, fair enough. We will now create a version 2 of that bounded task flow, and that's obviously attached to application A. But what about application B? Should it automatically upgrade to version 2? Well, if it does, well, maybe we need to regression test that application. Now, regression testing can be a complex exercise. It may be required that you do it manually because you don't have any automated tools, or even if you do have automated tools, well, maybe you've got to go and build all those automated tests. So maybe you'll go, oh, we don't want to regression test that application just at the moment. We're quite happy with version 1 of that Banner Task Workspace. Okay, so application A is using version 2 of the workspace and application B is using version 1. When you come to build those applications, you now need to not only map the dependencies, but you need to map the dependencies of the different versions. Ooh, this gets really complex because when you've got 500 Banner Taskflow workspaces with lots of different versions and lots of different applications requiring those different versions, you've got to track all of this. Now, this requires disciplined teams and also probably tools to assist you. Tools such as Apache Maven and Apache Ivy are designed to assist you with this dependency management and build issue. And while JDeveloper 11G currently has rudimentary support for Apache Maven, in our future build, we pretty much said that we'll be taking Maven as a first-class citizen to assist with these dependency management issues. So as a highlighted option here, I really do say to you that you should be having a look at Apache Maven, to look at integrating and solving these problems. And when JDeveloper 12c comes along, you'll be already primed and ready to use that facility for your future developments. Another extension of this, the sum of the parts application architecture pattern, I should say, is the cylinder architecture, which we'll talk about now. Now, the characteristics of this pattern is it is an extension of the sum of the parts. And now our application is made up of what we'd like to call many cylinders. Now, that's our terminology, but it was the best terminology we could come up with. And a cylinder encompasses or is effectively a self-contained business or function area of your overall application. So maybe you're building an enterprise application for your business made up of HR functionality, financials functionality, and so on and so forth. Well, they could all be separate cylinders. And particular point of this architectural pattern is that each cylinder becomes its own application workspace. All right, well, that's one of the characteristics of this particular pattern, but why are we attempting to model it this way? Well, one of the goals of this architectural patterns and one of the trade-offs is that one of the things we want to try and avoid, as we were talking about in the previous section, is we want to reduce some of those dependency management issues. And one of the areas you're going to get dependency management issues is where you have dependent ADF libraries such as Banner Taskflow workspaces, or as example, the model project that is continuously changing. As you're building applications, that the business model of your application is something that goes through a lot of churn, particularly for bespoke or greenfield applications. So if it's going through a lot of churn and it's got lots of different versions shooting out, that's going to have an effect on the rest of your application. So could we potentially reduce the number of dependencies we have, or could we trade off reducing those dependencies to try and avoid that problem? And this is what this particular architectural pattern is also attempting to achieve. Again, let's look at this diagrammatically. So in this particular diagram, what we see on the right-hand side, and this was familiar to us from the previous diagrams, is we do have a common workspace with a number of common elements. But notice what is missing, the model project. With that in mind, on the left-hand side, yes, we're going to have one or more cylinder workspaces, but in this case, the cylinder workspace has its own model layer. And the model layer, like previously, also, I should say the cylinder workspace, like previously, also has a view controller project and its number of bounded task flows. But the key point to highlight here is the workspace also has its own model layer. And when we look at the other workspaces, yes, they also had their own model layer. Now remember that trade-off I said before? Rather than having the model layer in a common workspace where we define the entity objects once, what we're saying in this workspace as I should say in this pattern as a trade-off, if to avoid the common or the model continuously changing and having an impact on the rest of our workspace, on the rest of our architecture, I should say, effectively we've put the model off into different workspaces and we've duplicated it. Now, we're not saying duplicated functionality here at 100%, Because if the first workspace deals with financial constructs or financial business objects, potentially it's the only one to have entity objects that deal with, financials, tables, invoices, and so on. Whereas the other workspace, if it's got to do with the HR space, well, potentially it will be the only one that has entity objects and business components that deal with, employees and so on. However, if there is a case where there is shared functionality in the business model, well, yes, you will end up with duplicate objects. Now, I can already imagine some listeners are going, oh my goodness, what are you saying? That means that, well, if we've got duplicate entity objects between the two workspaces, if we need to do an update to one of those EOs, we're actually going to have to do it in two workspaces. Yes, that's the trade-off here. And we're trying to say to you, well, sometimes you may need to make trade-offs to defeat other issues that become prevalent or big problem in your overall architecture and your software builds. I'm not saying you have to pick this architectural pattern, but we want to highlight the trade-off to you. Now, returning to the concept of the cylinder architecture, you'll notice in each cylinder, we just basically say bounded task flows here. You can have as many bounded task flows as you want, but the idea is that the bounded task flows here are aligned to one cylinder or one business function or functional area. In the end, you still present one master workspace in the end with one unbounded task flow and one deployment artifact. The design considerations of this architectural pattern is, well, you don't really just need to put all your business functions, such as all the HR or the procurement or the financials, in one cylinder or what maybe you might want to call a silo. You can actually split your functionality by different use, maybe. Okay, we try to give you an example here, but you might have some lateral thinking that breaks the cylinders up in different ways. Of course, then what goes into a cylinder? How fat or thin should your cylinders be? If we take an example of financials, maybe that's one huge fat cylinder, or maybe you need to break that cylinder up into smaller cylinders for financials, such as something that deals with invoices or procurement or whatever. Okay, so maybe you might have more cylinders than the big fat silos that I was talking about before. So how fat or thin should the cylinders be? What functionality goes in them? Where's the logical line drawn for each cylinder? Really up to you to decide. But of interest, okay, we're not talking about bounded task flow granularity here, though that's still a design consideration, but we've also introduced a design consideration of how fat or thin these cylinders should be. The advantages of this particular architectural pattern is, well, we're reducing specifically in this example, the dependencies on the most actively changing part of our application build, which would be the model layer. So it's a trade-off, right? We're effectively trying to eliminate that guy because he's having a large impact on all our build and all the changes coming through on the rest of our system. We've also devised a way now to say, well, you should logically group your BTFs together in a cylinder. You should be something that you're thinking about. In the previous architectural patterns, we just kind of said, well, it's up to you. We want you now to think about that in this architectural pattern. And the third bullet point here is an interesting one. From a team and project point of view, we are now actually grouping or building our application at such a large level. We have these large cylinders that can actually shape our overall development and also our project phases and so on. Because once your teams are skilled enough to build this architectural level, okay, and obviously it does take time to get your teams getting up to the skill of building totally reusable applications using ADF libraries and bounded task flows. But once they're skilled with that, maybe you want to actually form your teams around cylinders rather than form your teams around individual bounded task flows, okay? Maybe this is something that you can do. Another advantage is, maybe this is an advantage or a disadvantage, but your regression testing now can be aimed at one cylinder rather than the whole application. Okay, though, within essence, we could have also done regression testing at the bounded task flow workspace level, but that would be more unit testing. So if we know we've created our cylinders fat enough that all the functionality is self-contained within one of those cylinders, we can regression test the cylinder, but we don't necessarily need to regression test all the other cylinders because they're disparate pieces of functionality. The disadvantages of this particular architectural pattern, yes, we're going to duplicate functionality in our model layer across the cylinders, and this will create a maintenance issue. And there's no lying here. We are breaking a fundamental tenet of software development. You will also need to version your application parts separately, but that's no different from previous. Just as the third bullet point says here, in addition, just to highlight it, we're not actually introducing an architectural pattern that isolates us from database changes. Okay, maybe the thought here is that some teams will get is, hey, if we put the model projects back in these cylinder workspaces, that will also assist us to avoid changing database changes in the database that will ripple down and cause us to change our solution. Doesn't really isolate you from that. We have lost a facility, a major advantage of one of the other previous architectural patterns, the sum of the parts. We really have, within the cylinder, we're actually breaking the rule of separation of concerns because we now could potentially start to tightly couple our code again. I'll get that point out. Now, hopefully, if your teams are disciplined at this point, well, they'll build the application so that they're still loosely coupled internally. But you can't guarantee that with this architectural pattern. Finally, this last point here is a very interesting one. One massive application may overwhelm the JVM resources, and that goes on to the last architectural pattern that we're going to present here. Now, in kudos to Gizmodo, the website Gizmodo, they had this very interesting website article a couple of months ago when this presentation was written. Now, obviously, the parallels of this presentation, yeah, we're talking about ADF application architecture, but we can also talk about the analogies to construction architecture. And you may be familiar with this particular building that's being built in Dubai. Might be finished at this time. And this building is the world's largest building at 828 meters. And one of the interesting points about this building and it being constructed is, well, with buildings and construction architecture, how tall can buildings actually get? Is there a physical limit or any major issues that we hit in building taller and taller buildings? Now, from what I understand, is apparently there is no limit. The only major issues they've been hitting in constructing buildings of this size is the elevator shafts, but they have solutions for that. But really, the same analogy comes along to us building applications in ADF. If our cylinders end up to be massive in their own right, and as a result, the single deployed ear is huge, is there a point when we can have problems in building applications of that scale? Is it possible that we may overwhelm our JVM, okay, our Java virtual machines? Let's assume there is. What would be the solution when we get to applications of this scale? That's where we introduce the pillar architecture. Now, bonus points to me, I've got pictures of Oracle's HQ in there with these perfectly formed pillars. But the pillar architecture really takes the idea in that we're going to build separate applications here. Let's talk about that in detail. The characteristic of this pillar architecture pattern is it's really an extension of the cylinder pattern, but each application, so each cylinder, is an application or a deployment or an ear in its own right. The trick being, though, even though it will be multiple applications that we will deploy, from the user's perspective, we may want to make it feel like one application. Let's look at that diagrammatically. Okay, so here we've got the common workspace on the right, and on the left-hand side, we have what looks like cylinder workspaces, and they've got their own model projects and their own view controllers and their own bounded task flows, but the significant difference is they have, that's right, their own unbounded task flows. So they are really applications in their own right. And yes, they do get deployed as separate ears or separate applications. And they don't necessarily need even to go on the same WebLogic server. They can go onto different WebLogic servers, different WebLogic server clusters. From a design point of view, therefore, we're actually separating this into separate applications, maybe separate WebLogic servers, but we want, from the user's perspective, this to make it feel like it's all one application. Now, I don't know if you're familiar with Oracle's Fusion applications, but this is exactly what it does. It is not one massive ear, one massive application deployment. It's actually multiple applications, all separate modules broken into multiple applications. And through the trickery, can I use that term, of single sign-on and a common user interface shell that wraps all the applications and some mechanisms behind the scenes that allow us to share state between the disparate applications, to the user, it feels as if it's one application. So, to coin a phrase, a fused application. So this is something that you may want to consider if you're building a massive application like Fusion applications. Now, not all customers will be doing this. Not all users or all customers or organizations out there need this architectural pattern. So we just making you aware of it. There are limits to what you can build. The advantage of this particular architectural pattern is you do get a fairly flexible change control procedure in some ways, because you can actually patch and redeploy at the application level, whereas with previously the cylinder application architectural pattern, if you had to patch at the cylinder level, you still then also had to redeploy the major workspace, the master or the composite workspace, and you effectively brought down all the other cylinders as well while you're doing that. But with the pillar architectural pattern, well, you're breaking your application into multiple applications, so you're really only bringing one application down at any one time. In addition, because you're breaking your application up into separate applications, one application won't necessarily affect the performance of another application if you separate it onto separate WebLogic servers. Okay, so you start to be able to divide the performance of your application up in that way. Disadvantages, well, ignoring the fact that you've got many applications that you need to now keep track of, but you're going to potentially have to implement single sign-on. Now, that's not necessarily an issue if you already have single sign-on at your site, but you may not. You may need to now buy it, configure it, and make sure it all works for your application. So in that way, it's a disadvantage. Single sign-on itself is not a disadvantage from the user's perspective. You, in addition, have to find mechanisms to share state between the applications, okay, such that the user's experience, say they change their user preferences for the screen colors in one application, that is shared across the other applications that they access in your one large application. Okay, so you do introduce more issues, more things that you need to build into your overall applications. Phew. So like I said, definitely a lot of content in that last bullet point, the application architectural patterns. What I'd like to do now is introduce some anti-patterns, okay? And the anti-patterns, again, just to highlight, are basically, well, they're lessons learned or ways that you don't particularly want to build your applications. And we'll see with some of these architectural patterns, it's just taking some of these anti-patterns, are basically taking building ADF applications to an extreme that you probably don't want to go down. Now, there are three anti-patterns that I need to talk about. In fact, I'm only going to talk about the first two. My mistake, I left a third bullet point here. But the first one I'll just verbally describe straight away. Everything is a template. We do know of one customer when building screens that they use templates and task flow templates and page templates absolutely everywhere to the nth degree. And they actually did it to the level that every time they built a screen with a table, every column within the table was based on a page template. Now think about that. Normally page templates, you have one per page, but at this point, if you have a table with 10 columns, they're potentially introducing 10 page templates, but an overall page template. That's just taking templating too far. Every time they design another screen, they have to introduce all these page templates again. You're really moving away from the drag and drop and the ability to quickly create screens in ADF to this over I'll try and get the word out, templatizing of your applications. This is not a particularly good thing, okay? So we're going too far. Taking that too far, this extreme reuse concept on board, let's take this second anti-pattern here, the fine-grained architecture anti-pattern, and consider that, and we'll actually consider that diagrammatically. So this is the gray architectural pattern that was in our original genealogy map. The architectural pattern here, the characteristics of the fine-grained architectural pattern is that in terms of our bounded task flows, rather than leaving it as a choice in terms of the granularity, large or small, all our bounded task flows, we'll see in a moment that this isn't exactly true, but mostly all our bounded task flows are reduced to the smallest granularity possible. And by this, we mean that we effectively only have one activity in each bounded task flow. With the goal being that, well, if there's only one activity in the bounded task flow, that means we can reuse all these little bounded task flows and all these little activities all over the place, right? And that might be a little bit hard to understand, but you'll see what I mean in a moment. Now, not all our bounded task flows are necessary at that granularity because in order to consume all these little bounded task flows, we need to wrap them in something. And to do that, we use a composite bounded task flow, effectively a wrapper to bring all the little bits that we need together into one larger bounded task flow. In order to build with this particular architectural pattern, okay, reuse must be absolute a mindset throughout the whole software build. And by that, I don't just mean, when you're building the software, but I mean the business analysts, right, who give you the requirements for your bounded task flows. They too need to be thinking about reuse. Reuse must be a consideration at every part of the overall build here. And reuse must be considered for all parts of the application build, even maintenance. Okay, you can't have a point in this application architecture pattern where you suddenly decide, well, we're not going to go for reuse, or can't we break this reuse model? Because this architectural pattern relies on you using the fine-grained granularity of the bounded task flows all over the place. Again, probably a little bit abstract at this stage, so let's look at a diagram. So rather than going into the architectural diagrams that we saw previously, let's actually take this screenshot from Fusion applications. Now this is a pretty standard laid out application. On the top you've got menu bars, on the left you've got navigation controls and in an accordion control, and on the right you've got the main bulk of the page, the edit customers part. Now what we could literally do with the power or the total flexibility built into bounded task flows is we could take that basic information block there and we could create a bounded task flow out of it. Okay, a bounded task flow based on fragments with one activity that simply shows the name, the primary URL, the address, and so on. And we might call that a service bounded task flow. Okay, so there's one bounded task flow. And that customer details bounded task flow, that becomes a customer details block, I should say, there becomes another bounded task flow. And the same with additional names and customer type and addresses. They all become separate bounded task flows. Wow, this one screen, okay, let's ignore the chrome around it and the menuing, but just that one bit with the main business functions in it there, we've already got 6 bounded task flows, 6 service bounded task flows. Now, in order to display them, we need to wrap them in something, so we need a composite bounded task flow, which is a region in its own right, that has those other bounded task flows embedded as regions. And you can imagine here we've got kind of an onion skin occurring. We're going to have to then wrap that composite BTF in more and more composite BTFs and eventually a page just to get this page laid out. How many bounded task flows are we going to end up with just for this one page? Literally potentially 20, 30, 50, and that's just one page. Oh, can you start to see where this particular architectural pattern goes too far? It's taking this fine-grained pattern and just applying it everywhere. So we've got thousands, potentially thousands of bounded task flows being built. A good idea, total reuse, extreme use, but just taking it to its ultimate extreme may be something we don't want to pursue. So the fine-grained architectural pattern is like an extreme sport. It's very interesting. You do really get extreme use coming on board, but the problem is that you will find that it's very painful after a while because you've just got so many moving parts. We've taken the reuse to the nth degree. It's going to be very difficult to keep track of everything, to build applications every time you make one little change to one of those little service BTFs, because they're built for total reuse, they could be used in thousands of different locations and you're going to have to retest all those different screens. Okay, maybe that's what we want to achieve, maybe not. I'll leave it up to you, but I think the point's been made. So the disadvantages here are not for the faint-hearted. Yes, you do get some performance issues because with these little bounded task flows, these service BTFs, because they may be called standalone, you may need to requery the data. You may need to do lots of requerying of data because they're not being used from the larger bounded task flow that's already fetched the data previously. Simple applications become overly complex with lots and lots of bounded task flows, and you end up with a house of cards where it's really hard to keep track of things, and you start to going, do we really want to keep all this going, or can we break the model? And then the whole architecture starts to fall apart. So you do need a strong team, and particularly strong team leaders, to follow the disciplined approach to implement this. And you do end up with the worst case dependency management here, because not only have we got maybe 20 or 50 bounded task flows to keep track of and build with and all the versions, but you may multiply that by literally thousands of bounded task flows now. So not particularly an architectural pattern
which we advise. The last point we'd like to discuss in this particular presentation is best practices. So one of the messages we want to leave you with here is the very first bullet point. Start small, think big. If you're a team who's just starting out, while yes, you want to ultimately build these massive applications, the problem is that your skills and expertise really aren't up to necessarily building the large applications and the more sophisticated architectural patterns. So yes, you can certainly have these grandiose dreams, think about what you're going to build eventually, but build up your skills on some of these simpler architectural patterns to start out with. Okay, don't just go for the Chris Muir showed me the pattern number 7, which seems to be the ultimate pattern that we should use for building all our applications. If you go that approach and you haven't built up your skills, you're effectively running before you've learned to walk or even crawl. And in children, that's a silly thing. They will fall on their face. And from a software development point of view, you will also fall on your face. ADF gives you the flexibility to build different scales of applications. Just don't think or assume you've got the skills to leap into a more sophisticated architectural pattern or software development straight away. That is folly, okay? And you should be very careful about doing that. In order to reduce that curve, there are certainly some things that you can do. Find help. Go out and find some consultants or experienced developers who can assist you through this. Now, if you're a team that's already gone through this learning curve, you've got this internally, but customers who are picking up new technologies shouldn't just attempt to do this all by themselves. Go out and find a consultant to help you. In terms of the architectural patterns that we've talked about here, okay, and we have talked about several, document the architectural pattern that you decide. And the patterns that I've done here are in a way a little bit simplistic. You may pick an architectural pattern that's a hybrid of these. You may pick an architectural pattern that makes some compromises that I haven't articulated here. But in doing that, make sure you document it. Because otherwise, how are the other team members, maybe your current team members, but maybe the team members in the future, how are they going to know why you did certain things in certain ways? Okay? And when you document those decisions, also communicate why you made the decisions in terms of advantages and disadvantages. Okay, otherwise they've just got an architectural document and they won't understand the deliberations that you've gone through. Okay. In addition, plan your architecture. Okay. Architecture is something that should be a part of your overall project phases and your project management. Learn. You will learn from your experiences. Don't expect to sit there and understand all of this straight away. You need to give time in your projects to learn and plan to learn. Put time into your project management plan that actually says, okay, we're going to spend a little bit of time building a small application here or learning how to use ADF libraries or how to do build management with Maven or a continuous integration server. Don't just leave these off your plan. Again, these large sophisticated frameworks like ADF and other J2E frameworks require that you have a lot of skills and in-house infrastructure. You need to plan and put time into your projects in order to work towards a successful project build. In terms of the actual architectural patterns that we've presented in front of you here, in terms of selecting each individual ones, do take time out to discuss each pattern and effectively compare them to your requirements, okay? Okay, don't just go, Chris Muir advised us we presented 7 patterns, so therefore we want pattern number 7 because it was the most advanced one. You need to consider each pattern by themselves and how they meet your requirements. And in considering those requirements, also consider your business's processes. Are you or do you have the discipline to build sophisticated applications at this stage, or do you need to build those skills up? Or is it even about, in terms of processes, what requirements docs, the requirements documents the business analysts are going to put in front of you? You may need to redevise your processes and you may not yet be capable of building very sophisticated applications. Again, consider your reuse requirements, and hopefully through this presentation we've really highlighted this concept of reuse can be a very good thing, but it can also be a thing that you can take too far. Do consider your team's size, do consider your team's expertise and capabilities, and also consider your organization's infrastructure, such as tools such as Hudson and Jenkins, and ALM tools such as your ticketing systems and so on. You will need lots of tools to support you in large application development.
Don't just assume that you can build a large application without those tools. You don't see in construction engineering, they don't go and build those large buildings in Dubai without lots of equipment to assist them. Software engineering is exactly the same, and you need to consider those tools and your team's size and expertise and capabilities when building large software development efforts. Finally, in the last slide of the actual presentation, ADF Architectural Best Practices, understand that there is no perfect solution. One size doesn't fit all. You are going to have to pick a pattern and pick some pros and cons and advantages and disadvantages and some compromises. That means that yes, you will have second guessing that occurs down the line. Okay, there is no perfect pattern that fits all situations. Hopefully you got for the last couple of slides, you should communicate those architectural choices and advantages and disadvantages to your team such that you don't keep on second guessing yourself down the line. Having been in a team leader position, I have seen the junior programmers go, why did we choose this? And from their point of view on what they're working on at the very moment, yes, it does seem like a bad decision. But they don't often sit back and look at the broader point of view. And if you've discussed the broader point of view and you've documented the advantages and disadvantages of the choices that you made, then you can basically say to those team members, yes, I understand where you're coming from, but we had these other decisions and this is a trade-off and this is why you have to do what you're doing. As we said, reuse is a good thing. Don't take it to extreme. Definitely consider your team and organization's capabilities. Don't create solutions that necessarily work against the overall framework. When we were looking at the fine-grained architecture pattern, because we're breaking the solution up into multiple service-bounded task flows, you can actually work against the ADF framework by, well, where you used to have master detail coordination, maybe in a page between two view objects and on one region of the screen. Because of the fine-grained architecture, you can actually literally break those two master detail parts into separate regions, into separate bounded task flows, and necessarily you lose your master detail coordination that's provided by ADF business components if you take that too far. So don't take the framework to its extremes and start losing functionality and productivity features. Finally, consider all your options and what are you hoping to achieve. Okay, and that was really the point of this overall presentation. While you've got your head down building pop lists and maybe bounded task flows one by one, sit back, look at your overall architecture and go, hey, what are we trying to build here? Simple application architecture or multiple applications or reuse? Sit back and think about your options here. It's very important to have a broader picture in mind. And this is really the importance of team leaders and architects. This is what your job is in bringing these applications together. So thank you for joining me for this presentation. Obviously a very long presentation, but hopefully a fairly powerful one, particularly for teams who are starting out with ADF development. This particular presentation is one of many presentations and collateral that we have out there for you to learn about JDeveloper. If you want to find out more about the collateral that's available to you, either follow our Twitter stream, hit Facebook, or the Oracle's JDeveloper product management blog, or if you head to www.oracle.com/JDev, plenty of tutorials, demos, software, discussion blogs, and a lot more about ADF in particular that you can learn about. However, again, sitting back, thanks for sticking with us today. A very long presentation, but hopefully very useful to you. And if you're particularly interested in discussing more about ADF architecture, can I encourage you to join the ADF Enterprise Methodology Group, or what's coined as the ADF EMG, where this is the sort of thing that we discuss all the time. Hopefully you can join us there and we can have these discussions tomorrow.